Hello guys, welcome to my YouTube channel Civility for Professionals by Untitled. In this lesson, we are going to study how to create a basic profile for a rehabilitation road project. Now, in my previous videos, I explained that rehabilitation road project is there is a road, an existing road, and we are going to improve it. When it comes to a new road, of course, you don't have any such trace. You have to find it yourself, and you have to do the design accordingly. So we'll see here. Now in my previous lesson we designed an alignment. Now in this lesson let's see how we can create a basic profile for a rehabilitation road project. So as usual, let's start Civil 3D program. Now in this one thing you can do is you can now in our previous lesson we created an align. So either you can open it or you can have a new drawing using your available template and then copy the alignment there. Now I will open file open. Now you know this alignment is the one we created. Okay, so open this. You can save it as file, save as, and then you can save it as say basic basic profile. Okay, so we can create our profile here. That's one method. Other one is, we can go to file new and then get our template and then save it as profile and open alignment drawing, copy the drawing and then paste it there. Both are same, so I'm not going to describe it any further. So with that, if you go to tool space, general tool space like this, and in the prospector, if you see the surfaces, there are two surfaces. One thing is EG, that is the one we created. NS is the default surface, so you can delete it if you want. In the alignment one, we hadn't done it, so I'll do it now. Even if it is there, no harm. Okay, so now we are going to create our existing profile. You can create the existing profile by profiles, create profile from surface, and then you check what is the alignment. The alignment that you are having, its name is DCL. That is the only alignment we have. Then here you have to add the surface that you created earlier to that alignment here using this add. Then you go to draw in profile view. Okay, draw in profile view, and you can give a profile view name. Usually we give EG, existing ground. Profile view style, there are many styles that you can use. So I usually use this one. So that means the vertical scale is exaggerated 5 times. Okay, because otherwise it is not very clear. So once it is being created, you will see what I mean by this exaggeration. So then go to next. Station range is 0 to 171. That is the length of the alignment. Next, then profile view height, you don't change anything here, because once the profile view is created, then you can change it. So get the default one what they are giving, and then profile display options, there's nothing you have to change. Go to next. Data bands, you have to select data set that you want. Now if I put highway design, here they are showing horizontal geometry, depth, that is cut or fill depth, design level, existing level, chain edge, and super elevation data. Right, that's one thing. So if you go to put road design, here they are showing horizontal geometry, depth, design level, existing level, and change. But they don't show the super elevation. So you can select whatever you want. So I'll put highway design, and then go to next, create profile view. So they say select profile view origin. You select a suitable place. So your profile is, that is the existing one. Here can you see, here they are showing horizontal geometry. Okay, horizontal geometry, then cut fill depth. Here 0 because now we haven't yet designed anything. Then the design level, existing level, you can see design level and existing levels are same. Okay, design level and existing levels are same. Why? Because still we have not yet designed anything. Here's chain edge, and this is the super elevation. Okay, so you can see the datum is -4, but you will see that this is in a very high elevation. So why it is -4 datum? Because there are some errors here. Can you see? These are the errors. So I'll close this tool space. So these are the errors due to the survey's problem. So because now you can see if it is 24 something, you cannot have something like here. So we don't know, it's not shown. Maybe 0 something. So in a road you can't have like this. So these are some errors. Okay, so you have to neglect them. So therefore we can set this datum, say something like say 20, and we will check, select the profile view, right click, profile view properties, elevations, specify date. Okay, then we'll see what happens. 20 because it's going down, so maybe you can use say 16. 16 is pretty okay, it seems. Okay, so we'll start designing an alignment, sorry, profiles, create profile from, now earlier we did profile, create profile from surface. Now this time we go to create profile by layout. Okay, they say select profile view to create profile. It's there. Give the name, usually I give FG, finish ground. Profile style is design surface, and voice label set is VC design. So press OK. Then as same as in the alignment one, you are having here a toolbar. So what you can do is first start using this toolbar, draw tangents. Okay, so you can draw tangents like this to match with this. Okay, so you have to match with the existing one, right, as much as possible. Here I'm drawing. What am I doing? I'm drawing the lines to match the existing profile as much as possible. Okay, then press enter. Now you can see they are showing, these are called VIPs. The VIP means IP points, the vertical ones. Okay, and you know, you should know now when it comes to say the gradients for national roads, the minimum gradient should be 0.3, right? Now here, okay, 1 minus 1.64, 6 something, 2 something, here 0.26. So you can't keep this, right? Later you will have to adjust. You have to have minimum 0.3% gradient. And another thing I'll tell you, now you see this is not very visible to the eye, right? So what you can do is you can thicken it like this. Select it, right click, edit profile style. So you can see line, you give the line weight as 0.35, and you are getting this here symmetrical parabolas. You increase the line weight here, say 0.35, apply. Okay, now it is somewhat clear, right? So after that, what you can do is you can add the curve here. So you have to refer the relevant design standards. Now if it is, now you remember in our previous lesson we considered 50 kmph. So the parabola should be 50. So you can get more free vertical curves, free vertical parabola. Then pick point near PVI. So give the curve length 50 here. Now this is your vertical curve, right? Vertical curve, it says vertical curve is 50, K is 10. So you have to check for this is called a crest curve, you know why this is crest curve. If you go this way, it is that curve, right? For a crest curve for 50 kmph, according to the ostrods, you have to have something like 9.8 K. So this is okay, right? But we'll see here. Then you try to put 50 here. It's not coming. No solution available. Why? Because there is no 25 meters from this end of this parabolic curve to this VIP. Okay, so some call it VIP, you can call it IPV or whatever you like, right? So what you can do is you can shift this IP somewhere here. So you can, right, here using move PVI, you can select it, specify new location somewhere here. Okay, then you can try using this one, give 50, right? But now you can see it's okay, but still uh, this is not matching with the existing surface, existing road. So what you can do is you can try moving this eyepiece somewhere there. See, select this one and come somewhere here, and again come somewhere here, right? You can press escape and check. And now here, look, this is the IP point. Select it and you go somewhere here, and select it, you go somewhere here, right? See, now it is going to be bit matched. Okay, and another thing, you can get this, say, profile layout parameters. There comes a table here, so you can pick an IP using select PVI. Select here, say a PVI station is 26, so you can make it 25, right? Right click, and then maybe if it is 25 here, so here 25, because the curve is 15, curve is 50, and here this curve is also 50. So from this center to center it is 25, from this h to, sorry, not center to center, from this center to h it's 25, from h to center it's 25, so it is 50. So if this point is 25, 25 plus 25 plus 25, it is 75, right? So you can put it as 75. Say PV station 77, you say 75. Okay, now if you want, again you can increase the PVI elevation 21.316. Why? Because it's not matching, right? Say 21.5, we'll see. Okay, like that you can design. Now here it is 160 something, 163, it is, no, it is not very proper. So you can select it and make it 160, say. Then you can try putting 50. Okay, now again you have to check K, right? K is okay because it should be greater than 9.8. But now when it comes to uh, the SAC, it should be 12, right? You have to check your table. Huh? You have to check your table depending on your table. As I remember, for the Ostrod it is 12. Now I am not referring it, but if you want, you can really refer and put, because I'm just doing some exercise. Okay, then here case okay, this one the gradient is okay, but here you can see gradient is not going to be okay, so you can uh, elevate it somewhere like this and check. No, it's not going to work, so you can remove it. How do you remove? Using this delete PVI and check. Delete PVI, then what happens? Both deleted. Okay, that's the problem. So you can select it here 50. So what's the PVI here? Say 150. Okay, then it's minus 27. You can't have minus 27. So one thing you can do is you can have a say IP point here, and what is this coming? 0.15. So try to make it. You select using this PVI, select PVI, you press it here, minus 41, you try minus 0.3 and then check what happens. Okay, now it's minus 3. After that it's minus 22. Don't put it that way, you make it plus minus 3 and check what's happening. Okay, so you can see that there comes a high fill. So one thing you can do is you can move this PVI along this line. Okay, then this point minus t will not change, but this filling will be reduced. You try it like this. No, now what happens? Then the filling is going to increase. So you do it other way around. You have to take it somewhere here. Can you see it is going to be changed? It is minus 43. You can always change it back to minus 3. Minus 3%. Minus 0.3%, right? Minus 0.3%. And then after that it is plus 34%. So you can make it, say it's 272. Say we'll say 270. No, yeah. And right click. And then you can have say plus 3 plus minus 0.3. So you can have 50 here, and maybe here having some bigger curve. Say we'll try 100 here. So you can reduce the filling, but anyway remember you have to follow this minimum gradient for drainage purposes. Okay, so like that you can complete the profile design. So after that you have to give the relevant labels for these things. Now if I select this, go to profile view properties, and then you go to bands. Here you can see horizontal geometry, so you cannot change it here. Profile 1, profile 2 you can't change. Then depth P1 minus P2, so P1 should be FG, our design one, EG. So profile 2 should be EG. So this is the depth. Then design levels should be finish ground one, the one we design, and the existing levels, so it should be EG, no change. Then chain edge, no, you can't, don't want to change. Super elevation we have not designed, so you can press apply and then OK. Now close this. If you go here, you can see cut and fill. Here you see there is a cut of 54 millimeters, cut of 170 millimeters. why this infinity? So that is there's some error, right? And here you have a fill of 70 millimeter. You have a fill of 25 millimeters and a cut of point 7 millimeters like this. Okay, and then the design levels are also there, existing levels are also there, chainage is also there, super elevation later we have to design, so you can save the drawing. Okay, okay guys, that's my today's lesson, how to create a basic profile for a rehabilitation road project. Thank you for watching. Please don't forget to subscribe and press the bell icon to get the videos like this. Thank you very much. Have a nice day.